problems 9, 10, and 11 from section 3.3, and this video is for the class Math 1324. Example number 9, it is related to example number 8, and for this problem, well, number 8, just to mention it, we were discussing the demand function. For that one, we established that Q was going to represent the independent variable. In example number 8, Q was representing the quantity demanded. Now for this problem here, for the supply function, Q is going to represent not the quantity demanded, but the quantity supplied. So the function, the independent variable, of course, would be the quantity supplied, and the price, the dependent variable, which is lowercase p, that will represent the price of the item. So what we're going to do here is find the supply if the price is $51 per unit. So they are giving us the value for the dependent variable, and we're going to find the independent, the quantity supplied. We do have the function, we have the equation of the function, and so what we're going to do is substitute the output with the 51, and we're going to solve for Q. So in this case, we will have 51 divided, well, I'm going to write it, you can see the 0.85 is multiplying to Q, so we're going to divide by 0.85, and that will give us our answer. So if we divide 51 by 0.85, we will get that Q is equal to 60. So at a price of $51 per unit, the quantity supplied will be 60. Now let's move on to part B. And that one says, find the price per unit if the supply is 20 units. So now we are given the quantity supplied, 20 units, and we need to find the price. So we're going to use the same equation. P equals to 0.85 times Q. And what we're going to substitute now will be Q with the number 20. Because that is what's given to us from the question. And so if we multiply 0.85 times 20, we will get 17. So $17, remember, that is representing the price if the supply was 20 units, if the quantity supplied was 20 units. For part C, it's asking us to graph the equation, and we already have the equation here. However, let's go over it quickly. So if the equation does not have a constant term, then we could assume that the constant is a 0. And if the constant is a 0, that will tell us that the y-intercept will be the point 0, 0. Remember, the constant term gives us the y value of the y-intercept, and by default, the x value of any y-intercept will always be 0. And we can see that point here on the line. And now, another thing we could have done was that we had 2 points from answering the questions. So remember, our variables, the independent is Q. So instead of plotting a point or writing a point in XY terms, we will say Q for independent and then P for dependent. So if I make a point with these two numbers here, it will be, the coordinates of that point will be 20, 17. And we could see that point here. Now, if we look at part A, we have Q equals 60 and P equals 51. So the point there would be 60, 51. And we can see that point right here. And remember, to graph a line, whether it's on paper or on my math app, all you got to do is plot 2 points and then connect them with the graphing line tool. So let's move on to the next slide. So example number 10. Now what we have here is the graph, the graphs of the previous two functions that we've been working with. From example 8, we had the demand equation. However, in example 8, instead of using 0.75, we had 3/4. To as the coefficient of the independent variable Q. So it is the same equation, but here we have it in decimal form. The slope, the rate of change, it is in decimal form. So example 9, we were looking at the supply equation, and we have it here. So the supply equation is the one that you guys see in blue on your screen. And the demand will be this one in pink, or now red. So we have those two lines graphed. And again, let's just review how Q is the independent variable for the quantity. Remember, both of these equations contain Q as the independent variable. For the supply equation, Q stands for the quantity supplied, and the Q in the demand equation stands for the quantity demanded. And so you could see here the numbers going from 0 actually to 80. Now the vertical axis, instead of being labeled as the y-axis, is representing the price. So we use lowercase p to label it. And we have the prices going here from 0 again. And here they're going by tens, so they go up to 70. Now, the question says, determine graphically whether there is a surplus or a shortage of supply at a price of $40 per unit. So first, let's see what these two words represent. So we're going to compare with an inequality symbol what would happen for you and able to have, or for any business to have a shortage of a supply. So will that happen when the demand is higher or greater, or when the supply is higher or greater? And imagine a shortage is like running out of something, out of certain product, or not having enough to sell. So in that case, it will be, the demand will be higher. So demand is greater than the supply, or the supply is less than the demand. Now for the other one, for a surplus, it will be the opposite. So we will reverse the inequality symbol. So in this case, to have a surplus is to have more than what you need. So in that case, the supply will be greater than the demand. So now let's look at the question again, and it says determine graphically whether there is a surplus or a shortage of supply at a price of $40 per unit. So what I'm going to do is look at the vertical axis and find 40. And there it is. Now we have this line being traced across the two linear functions for the supply and demand. So what we need to determine is the quantity for that particular point first, and that will be the quantity demanded. Now here for that, we could actually divide. If we were to substitute in the demand equation, I mean, I could estimate that it will be like a 25, but I am not sure, so I'm going to try to give you a better number. So I'm going to use the demand equation, which is P equals to 60 minus 0.75 Q. And remember, that's the line in red. And so if I substitute P with a 40, this will be 60 minus 0.75 Q. So in this case, if we say 40 minus 60 is equal to 0.75 Q, negative, by the way. So in this case, we will have negative 20 is equal to negative 0.75 Q. So negative 75 is multiplying to the Q. And so to solve for Q, I will need to divide by negative 0.75. Now, if we are dividing two negative numbers, that will be 20 divided by 0.75. And so that will give me 26.66. We're talking about quantity, so I'm going to go ahead and, well, let's use 26. So this x value right here will be 26.66. Let's just use that. And that will be the quantity for the demand at that price, at the price of 40. Now let's do the same, but now with the supply equation with this one. So we substitute, I'm using this equation here, we substitute P with a 40, and then we need to solve for Q to find the quantity that will be supplied at that price. So to solve for Q, and I believe we did this problem already. So we will have 40 divided by 0.85, and that will give me 47. So I'm looking for the Q value of this point, and so that will give me 47.05. So let's use 47. So now you can see that at that price, the quantity supplied is higher than the quantity demanded. We could say the quantity supplied, or the supply, it is greater, the supply is greater than the demand, because we're comparing 47 and 26.66. So in this case, we're going to go with supply is greater than the demand, and therefore we will have a surplus. Now let's go to the final problem of this section, and that is example 11. So in this situation, describe in examples 8, 9, and 10, what is the equilibrium quantity and the what is the equilibrium price. And so we have this thing called the equilibrium point. And that one, of course, it's a point, so it needs to have two coordinates, Q for independent and P for dependent instead of X and Y. And so that will happen whenever the two functions or the graph of those two functions intersects. And so that will be right here. Now that point, it looks maybe like that could be a 35, and maybe the price will be, I don't know, 30. It could be 31. I'm not so sure. So I'm going to guess that the coordinates of that point will be 35, 30. However, that I could be wrong. So what I'm going to do is solve for that, find the coordinates of that point algebraically by taking each of the equations, the supply and the demand equations, and solving them as a system of equations. So the coordinates of that equilibrium point that I was mentioning will be the equilibrium quantity and the equilibrium price. And so those two, I'm sorry, not P, but Q. And those two values will give us, together, will give us the equilibrium point. Combined, this is called the equilibrium point. So the first equation that we used was the one for demand, I believe. And I don't want to switch the slide because then I'm going to lose what I have written already. So it goes like this: 60 minus 0.75 Q. Now the other, and this was for demand. So the other one was the equation for supply, and that was P equals to 0.85 Q. So like I was saying, the intersection of those two lines is the same as the graphical representation of that intersection point is the same as finding the solution to the system of equations in two variables, with the variables being Q and P. So one way to solve it is by substitution. And so we already have these two equations written in terms of Q. So what I can say is that the price here, we want to find that point of intersection where the price is the same. So what I'm going to do is replace this letter or that variable with this expression. So it will be 0.85Q is equal, and now I'm going to write what I have here on the right side. 60 minus 0.75Q. And now to solve for Q, we could have the negative 0.75, which is subtracting on the right side. We could take that across. Therefore, it will be doing the inverse operation, which is addition by 0.85, but 75. And that equals to 60. Now, if I combine my terms here, 0.85 plus 0.75, that will be 1.60. Q is equal to 60. So now to solve for Q, it will be 60 divided by 1.60. And so Q will equal to 37.5. Now, if you have a question like this on my math lab, make sure you pay attention as how they want you to round and enter your answer, because they might tell you to round to the nearest integer. So in that case, it will be 38. Especially if it's, I don't know, some type of item that cannot be divided. Now, once we have one of the variables, the numerical value for one of the variables, we can take either the demand or the supply equation and substitute what we found for Q. Now, I personally find it easier if we substitute it into this one. So we're going to say if that equation says P is equal to 0.85 Q, and we already found a value for Q, we're going to replace that variable with the numerical value found here, 37.5. And we could just enter this on the calculator. 0.85 times 37.5, and that will give me 31.875. Now, this is the price, and so in general, for price answers that are related to a price, my math lab will ask you to round to the nearest cent or the nearest hundredth, or to keep 2 digits after the decimal point. So in this case, because we have a 5 after our second number, that 5 will cause that 7 to go up by 1 digit, by 1 integer, and so it will be 31.88 for the price. So now, just to summarize this, the equilibrium point, the coordinates for that equilibrium point will be, I'm going to go ahead and just leave it like that at 37.5 for Q. And for the price, we obtain 31.88. So that will be the answer for the equilibrium point. The 37.53, it is the equilibrium quantity, and the 31.88 is the equilibrium price. Together, they form the equilibrium point, and I'm going to show the graph one more time. That point will be here. So the coordinates for that point are 37.5, comma 30, I forgot what the last one was, 31.88. And that is the equilibrium point where the supply and the demand are the same. So this concludes the end of the video. Thank you for watching.